Yes, some of your assignment today goes into tomorrow. You don't have a work day, but you'll have a lot of time tomorrow to work. Okay, here we go. We pick up with number 5, okay? So, you guys learn how to do the product rule. I'm sorry, the chain rule very well. Now we look at problems where you have to do possibly the chain rule with the product rule or something of that nature. Can you see that this does involve doing the product rule along with the chain rule? Now, here's what people struggle with, and I do not pretend to convey this very well, but I promise you I've worked hard over the years to try to find a way to communicate this to folks. All right. So the question is, what do we set up first? The chain rule or the product rule? And here's the best answer I could come up with asking teachers over the course of years. And here we go. Here's how you decide what to set up first. You do it according to order of operations. If you were to plug in a value for x, you would multiply it by 2. You would then take 4 minus whatever that was. You would raise it to the 4th power. And then the very last thing that you would do is take 2x and multiply it by whatever that is to the 4th power, right? That's the last thing. So whatever you do last, that is the outermost structure of your problem. So we will set up, because this is f, I'll use 2 different variables. We use h prime g plus g prime h. So f prime of x is equal to, what is the derivative of 2x? 2 times 4 minus x raised to the 4th power. Plus, I like to often write the 2x first because multiplication is commutative, so I can switch that around. It's not a big deal. But now I need to take the derivative of 4 minus x to the 4th power. How do I do that? Chain rule. What's the inside? 4 minus x. What's the outside? What's the derivative of u to the 4th? What's the derivative of 4 minus x? Multiplying, we get negative 4 times 4 minus x to the 3rd power. So that's what goes here. That was my g prime. Question. Because you have a constant. It's when you have something that involves change. Because 6 is just a constant. There is no rate of change to it, is there? All right. Times negative 4 times 4 minus x to the 3rd power. There we go. So f prime of x is equal to 2 times 4 minus x to the 4th minus 8x times 4 minus x to the 3rd. You may want to leave it like that. However, you will not be allowed to. In this type of situation, you remember we asked before about when you simplify in the product rule and when don't you. This is one time where you're going to simplify. And every time I've seen this kind of problem in the AP exam, you simplify this expression. And the way that you simplify it is you write it as a product, which means we factor out the greatest common factor. And you're going to see that it looks pretty nice in the end. What is the greatest common factor between these two pieces? 2 and 4 minus x to the 3rd. Each one of these has a 4 minus x to the 3rd, and each one of these has a 2. And I take the 2 times the 4 minus x to the 3rd out of here, what's left? 4 minus x minus, I take it out of here, what's left? 4x. So f prime of x is equal to 2 times 4 minus x to the 3rd. And then I can simplify this. Negative x and negative 4x make negative 5x, so 4 minus 5x. And actually, I can take it one step further. Can I distribute the 2 to the 4 minus x? No, because it has a cubed on it. I can't do that. Can I distribute it through to the 4 minus 5x? Yes. So the derivative ends up being 8 minus 10x times 4 minus x raised to the third power. And that's a nice way to write it. You may wonder, why is that better than how we started? You'll find out in chapter 4, because we can tell a lot about the characteristics of the derivative right now. If it's factored, setting it equal to 0 then is pretty simple, isn't it? And we would see that the zeros of this function would end up being 4 and, let's see, 5/4. And so 4/5, whatever. So anyway, that would be helpful for us, okay? So let's move along. Flip your notes over, because we did the other problem, correct? Yesterday? All right. So we will end here, and we'll quick set this up, and then we'll head to lunch. We'll come back, and we'll do some challenging problems. I want you to know that the 4 problems we do today at the end of our lesson, they will be, I think that they represent the most challenging of the algebra problems that you would do on your AP exam. So having learned those, we should feel pretty good moving forward. Okay, we're not going to actually do these. We're just going to set them up real quick, okay? Because people need to make sure we know how to set them up. What's the inside? Outside? Good. Inside? Outside? Do the 1/3. This will finish off when we get back. Because I know you guys know how to do it from here. We've already practiced this. You guys did checkpoint on it. You did well. I think we just need to save some time here. Do it. Let's go. Okay, so already did that. And so here, yes. So we're flying through. Hannah asked, why aren't we going to do them all? Because we don't have time. But we are going to look at the inside and outside so we know how it's set up. What's the inside? 2x minus 3x squared. Good. I said, what's the inside? Because inside is often easier to identify. What's the outside? -10 to the -5th. Very good. Yep. And what's the inside? And the outside? Good. Got it, folks? Super duper. Let's do A, B, C, and D. I don't know if we're going to be able to finish them all. For some reason, this class always seems shorter, and it's probably because of lunch. So A, we have to decide whether we use, all these involve the chain rule, okay? But they also involve either another chain rule or a product rule or a quotient rule, multiple pieces. Smile, Annika, otherwise your face will stay like that, okay? All right, so what do you think? Other than chain rule, what does it involve? Product rule, very good. Quotient will be divided, sorry. This is times. Okay, so what do you think we set up first? Do you think the outermost structure is the product rule, or do you think the outermost structure is the chain rule? Don't write this down. Don't write this down. Guys, if it was like that, then the outermost structure would be chain, and the inside would be product. But in this situation, if you were to plug in a value for x, you would multiply it by 4, take the cosine, you would you'd square it and multiply by -3, and then the final thing you would do is you would take whatever that 3x squared was, and you would multiply it by the cosine of 4x. That's the last thing you would do, right? So according to order of operations, that means that product rule is our outermost structure. So I have h prime g plus g prime h. Therefore, f prime of x is derivative of -3x squared, -6x, times the cosine of 4x. And I'm going to write the h first, so -3x squared times derivative of cosine of 4x. What do I do to find the derivative of cosine of 4x? It is a plus, but because it's a negative 3x squared. And then, Miss Hannah, you said I have set up the chain rule, right? Oh, okay. Yes, you did. And so the inside will be 4x, and the outside will be cosine of u. You have to see that it's the composition of two functions. Nope, totally wrong. So here's what you got to start to do, because we're going to start to skip this step after a while. And you have to be able to catch up with us, okay? Otherwise, it's just going to take forever. When I want to take the derivative of cosine of 4x, what's the derivative of the inside? 4. What's the derivative of the outside? Negative sine. So the derivative will be negative 4 sine of 4x, right? Now, I drew the boxes, and we're going to do it just like this, but we're not going to do this every time. There will come the time where I won't draw the box anymore. I expect you to see that the derivative is negative 4 sine of 4x. Okay? So I'm going to start talking about the derivative of the inside times the derivative of the outside with the inside left alone. So I get f prime of x is equal to negative 6x cosine of 4x plus, what are you talking about? What do you mean? Thank you. Now I understand what you're asking. Look at the rule. It says h prime. So I take the derivative of that. But I do not take the derivative of that. So I don't, the chain rule is what I do when I take a derivative. So I didn't take the derivative of that. So I just leave it as cosine of 4x. Does that answer your question? Okay. All right, and that's done. If you wanted to, what could you factor out? The 6x. I'm going to allow either type of answer on the test. I'm really looking for problems like what I showed you earlier. Say this one right. No, where was it? Sorry, other page. Right here. So when you have this type of situation, I want that factored. When you have, this type of polynomial piece, that can be factored nicely. Okay. All right. We move on. You might need a scratch sheet of paper for this. It does take a little bit of space. So we're going to go the square root of 2 minus x over 2x plus 3. And I would say if you could do this problem, that would be the most rigor that you would see on an AP exam, in my opinion, for a derivative type problem involving algebra. So we can do it. What do you think the outermost structure is? Chain or quotient? Why? Right. You might say, well, what would it look like if it was the outermost structure was the quotient rule? Let's say you had the square root of 2 minus x over 2x plus 3 to the 4th. Well, then you would set up the quotient rule, because the very last thing you would do would be divide those two things. But the very last thing that we do is take the square root of it. So we will start by setting up the chain rule. What is the inside? So what is the outside? What's the derivative of u to 1/2? Very good. 1 over 2 roots of u. Because it would be 1/2 u to the negative 1/2. As I said before, it's good if you could just start to memorize that. We use it a lot. Okay, how do I find out the derivative of 2 minus x over 2x plus 3? Quotient rule, right? What's the derivative of the top? Negative 1 times the bottom left alone, 2x plus 3. Takes 1 to know 1. Minus, what's the derivative of the bottom? 2 times the top left alone. 2 minus x, all over 2x plus 3, that quantity squared. Let's simplify the top. Negative 2x minus 3 minus 4 plus 2x all over 2x plus 3 quantity squared. All right. So what cancels? Yep. So we get negative 7 over 2x plus 3, that quantity squared. So that's the derivative of the inside. Could be kind of icky, huh? Can you see it? You see it's going to get bad? Because you're going to put a fraction into the denominator, aren't you? You got a fraction in the denominator. That's called a complex fraction. Ooh, there it is. Every day, right on time. Thank you for changing the color scheme. All right. So let's write it out. 1 over 2 times the square root to save space, can I write it like this, please? 2 minus x to the 1/2 over 2x plus 3 to the 1/2. If I take the square of the whole thing, that's the same as the square root of the top over the square root of the bottom. I will include this piece in a second. Times negative 7 over 2x plus 3 quantity squared. In order to simplify a complex fraction, I need to make one fraction over one fraction multiplied by the reciprocal, right? So here we have 1 over 1, right? And here we have 2 times that over that. So if I multiply by the reciprocal, what's going to be in the numerator? 2x plus 3 to the 1/2. What's in the denominator? Oh, hey, what do you notice? Yeah, the 2x plus 3, those are the same base. So we can reduce the exponents. This is the 1/2, this is squared. So we're going to end up with something in the numerator or denominator. Denominator, and so I got to subtract 2 minus 1/2 is 3/2. So I'm basically done now. I can write the numerator. I have negative 7 on top, and on the bottom, I have 2 times 2 minus x to the 1/2 times 2x plus 3 to the 3/2. And that's my derivative. What do you think? Not too bad? All right. Ready for our last two? We got 2 more. The next one's not quite as tough as this, and the last one's easy. You'll see it right away. Okay, what do we got? What's the next one? What is it? Letter C? What do we got? Read it off. Okay, outermost structure, product, chain, or quotient? Quotient. Why? Last thing you do is divide. So we'll set it up. F prime G minus G prime F all over G squared. F prime means I take the derivative of the top. In order to take the derivative of the top, what do you have to use? Chain rule. See if you can do it. See if you can do it without drawing the boxes. What's the derivative of the inside? 3. What's the derivative of the outside? 4u to the third. So it'll end up being 12u to the third, right? There we are. All right, well, I'll write it out. You need to get to a point. Eventually, you need to get to a point where you see it, because we won't write it out every time. What? No, and I will, in my work, I draw the boxes. If I have, like, say, 3 chain rules, I will start to do the boxes. Yeah. So we've got 4u to the third, and this is 3. So as you multiply them together, like we said, you got 12u to the third. So we get 12 times 3x minus 5 to the third power times g, which is 2 minus x to the 6th, minus. Okay, now I got to take the derivative of the bottom. How do you take the derivative of the bottom? Chain rule. Try to do it without writing out the boxes. What's the derivative of the inside? -1. What's the derivative of the outside? 6u to the 5th. So therefore it will be -6u to the 5th. -6u to the 5th. No box. Not too bad, huh? If you have to draw the box, draw the box. Nice. I wanted to do one without it, okay? And then times f. F is 3x minus 5 to the 4th, all over g squared. So what's in the denominator? Now, what do I got? 2 minus x to 12. What do you notice? A lot of exponents, good. 2 minus x. I've got 5 of them that I could get rid of, right? I've got 5th power here, 6th power here, and 12th power here. So that means I can factor out a 2 minus x to the 5th out of the top, right? And when I do that, what's going to happen is all of these will be gone, right? This will be reduced to what power? 1. This will be reduced to 7. Can I distribute the 12 to the 3x minus 5? Can I distribute the 12 to the 2 minus x? Yes. So I have 3x minus 5 to the third times 24 minus 12x plus 6 times 3x minus 5 to the fourth, all over 2 minus x to the 7th. Because I took 5 out of the top. So 12 minus 5 is 7. So those 5 will cancel with 5 on the bottom, leaving the 7. What? You can't multiply through when it's got a power on it. You would have to cube it all out first. But you can do it to this one. No. No. So what is now the common factor? 3x minus 5 to the third power. When you take that out, you're left with 24 minus 12x. Then what? Plus 6 times what? 3x minus 5. So plus 18x minus 30. I took it out. It was reduced to the first power when I took it out. And final step, can I combine any like terms? How many x's? 6 x's. Yeah, so I took out a 3x minus 5 to the third. So nothing, when I took that out, there was nothing left here, right? It's sitting right there. And when I took it out here, it reduced it to 1. So you had 6 times 3x is so on and so forth. Okay. All right, so you end up with 6x, and then a minus 6 all over 2 minus x to the 7th power. Anybody see what is one last step that they may do on the AP exam? Take out a 6. Now, you don't necessarily have to go that far, but you do need to write it as products like that. So, again, I think the most algebra-intensive type problem you would see on the AP exam. And I think you can do them. And you're going to practice them in your assignment. One more. We'll be done. And then short 2 problems tomorrow. And then after that, you'll have a lot of work time. So, whoops. What am I doing? Here we are. Okay, let's look at problem D here. Nope. What do you think? Do you see the product rule? No, there's no product rule. See the quotient rule. But it is the chain rule, and it's the chain rule twice. What is the last thing you would do if you plugged in a value for x? What's the last operation? Times by -8. But what would you times by -8? Something to the 4th power, right? So -8u to the 4th power. What is that thing you're taking to the 4th power? Sine of 4x minus 2. What's the derivative of -8u to the 4th? What do I have to use to find the derivative of sine of 4x minus 2? Chain rule. Now, some of you could just do that by looking at what's the derivative of the inside. 4, what's the derivative of the outside? Yeah, so there you got your answer. So you end up with 4 cosine of 4x minus 2. My final answer, I multiply these together, and I substitute u back in. What's -32 times 4? -128. Sine of 4x minus 2. Where do I put the cube? Do I put it after the parenthesis or over the sign? Over the sign. You're cubing the operation of sine, not the 4x minus 2. Right here. That is your answer. Okay, you need your homework sheet, you need an assignment. Here's your assignment.